Hello students, welcome to IMS Academy. In the last session I started how to solve gate questions, but I give the 2023 questions and I solved each and every one of the question also now. In this session I am going to solve the problems which were asked in the year GATE 2022. Certain number of problems we can tackle now. You will understand the way of doing each and every question. Understand now. This is one of the EDC question, GATE 2022. What is given in this problem? Consider a long rectangular bar of direct band gap p-type semiconductor. The type of semiconductor is a p-type. Is given. The equilibrium hole density is 10 power 17 per cm cube. That means the hole density what is existing here given now. Hole density means conduction band or NC or NV. This is a p-type, NV value is given here now. Hole density is given. And intrinsic carrier concentration is 10 power 10 centimeter per centimeter cube. Ni value also given in the problem. The hole diffusion length and also electron diffusion length are given. Ln and Lp values are given. The left side of the bar x equal to 0 is uniformly illuminated with a laser. By using the laser, illumination is done one end, having photon energy greater than the band gap of the semiconductor. But always it is a must, photon energy must be greater than the band gap energy of the semiconductors is a must to illuminate. Excess electron hole pairs are generated only at x equal to 0. In the rectangular bar at x equal to 0, excess electrons and holes are generated, it says. At x equal to 0, what concentration is developed, it is given now. Under these conditions, we have to find what we have to find finally. Steady state electron density at x equal to 2 micrometers is. Such a way question is asked. 4 options are given. Initially, this problem I want to give in the hands of the students only now. How many number of students are going to give answer very perfectly? Can you try this question without my help? At first, you try and give me the answer. Just to take 2 minutes. If you are getting answer, very happy. Just I will check what answer you will give. What answer you will give, that I want to check. What answer you can give? Anybody? Anybody having any idea about it? Shall I do this question? Shall I do this question? Yes, you please watch. This is given a rectangular bar, as I will do here now. You please watch. This is one of the rectangular bar. There is one rectangular bar. This way we can draw. This is a rectangular bar. Is given here now. And there what now laser light is here, applied this side. X equal to 0 here. Some length of this conductor is there now. There what he says, whenever the laser light is here incident, what is going to happen? In the semiconductor is nothing but in the problem it is given p-type extrinsic semiconductor. That point is very important. This is p-type extrinsic semiconductor it is given. But already that p-type extrinsic semiconductor can have certain number of electrons and holes. P-type extrinsic semiconductor, p-type means holes will be more only now. Na concentration of the electrons holes will be had by the p-type extrinsic semiconductor. Na, P is approximately equal to Na. Na is a very large value. Catch my point. When the illumination of the laser light is not made, already in the p-type extrinsic semiconductor contains how many number of the holes means Na number of the holes. What concentration of electrons are existing? N suffix 0. Those electrons are the minority carriers only now. Sir, how the generation of these electrons are possible in p-type extrinsic semiconductor? Because of the atmospheric temperature. When the exposure of the temperature is made, that will be absorbed by the material now, and immediately certain number of the electrons will be forming only. They are the minority carriers in the p-type extrinsic semiconductor only now. When the laser is made to apply to the one end, what is going to happen? That light energy, laser light will be taken by the body, and it is going to develop the number of electrons and holes inside of the material. But I can say here the number of the holes I am not going to consider. What number of the holes are generated in the p-type, I don't want to take. Why, sir? Already p-type extrinsic semiconductors can contain majority carriers, the holes many. That means because the illumination of that light, the number of the holes in extra it came are a negligible only. There is not a big amount only now. But the p-type extrinsic semiconductor can have the minority carriers of electrons N0. Because of this laser light, what happened now? Certain number of the electrons also in generating now. Electrons are to be taken into account only. Electrons, even few number of electrons are increase in the p-type. The total number of electrons in the p-type will be more only now. Total number of electrons will be more only possible. I will give the clarity. Even not followed, you can understand clearly now. What I wish to say, suppose I selected here, this is a x-axis I have taken. You will understand clearly now. This is nothing but the concentration of electrons. So it's a p-type semiconductor. If it is given p-type, you must consider the minority carriers only. Majority carriers we are not going to consider. P-type means N only you must take. N-type is given, you think it's so. Holes only you must take. Because the change due to the illumination will be more possible in the minority carriers only. That's why we are considering minority carriers only now. Understand now. And also in the what data is given, please watch. Then after we can enter now. What data is given in this problem? Consider a long rectangular bar of direct band p-type semiconductor. The equilibrium hole density is 10 power 17 per cm cube. Hole density means acceptors concentration is given here now. Na is given in the problem only now. What Na is given here? Acceptors concentration is equal to 10 power 17 per cm cube it is given. One value we got here now, given that value. Try to understand, very simple question now. And the intrinsic carrier concentration is 10 power 10 per cm cube, 10 power 10 intrinsic concentration. I will take it as a Ni. 10 power 10 per cm cube, I can note down here. That much intrinsic concentration is given. And also in the problem, what is given here now? The electron and hole diffusion lengths are given. Electron, Ln is given 2 micrometers. Ln, diffusion length, Ln is given. Ln and Lp is given here. What is Ln here? Ln equal to 2 micrometers. And the Lp equal to 1 micrometer, it is given. These values are given here now. And next what is given now? At excess electron hole pairs are generated because of this photon energy only now. The steady state electron density at x equal to 0, what density of charge carriers are existing is given. 10 power 14. What it says, at x equal to 0, the concentration here existing is 10 power 14, it says. This is a per cm cube only now. This is per cm cube only. What concentration is existing at x equal to 0? Clearly watch. At x equal to 0, 10 power 14 cm cube the steady state electron density only, not hole density, electron density in the p-type only, no, it is given. Next one, under these conditions, electric field is neglected. At X equal to 2 micrometers, I want steady state electron density. That means electrons, that means what now? X equal to 0, this much. When the electrons are generated, what is going to happen at the one end of the material, excess electrons and excess holes are generated. Then what happens now? They are going to diffuse in the material. They are going to diffuse only now. Because the diffusion, you know very well, the diffusion will be done like this only. Electrons will be diffused like this now. But already the p-type extrinsic semiconductors can contain certain number of the minority carriers because of the temperature. That can be taken as a what now? N suffix 0. This value is taken N suffix 0. That means the diffusion is done, slowly it goes and reaches to N naught only now. Because the diffusion, they are going to move, right? It reaches to N naught finally only now. Anyhow, this is nothing but I can note down from here to here, this value I want to take it as a, this value. This is nothing but N dash of 0 I have taken for example. This is N dash of 0. At X equal to 0, how many number of electrons are existing? Electron density only now. At X equal to 2 micrometers, I want X equal to 2 micrometers, catch my point. At X equal to 2 micrometers, what is asking? The electron density is required. The density of electrons required. This concentration I want. What is this concentration? That concentration I want. This concentration I can say N dash of X equal to 2 micrometers. 2 micrometers only. 2 micrometers I want. N dash of 2 micrometers I want. But just like a what? Discharging of the capacitor. You are going to get what now? The shape of the waveform only you can see. But how we can measure, what is, this is the, when the discharging, just like a discharging of the capacitor we are getting, because the diffusion, electrons are going to move. So these electrons are nothing but N dash of X at any point. N dash of X at any point. X equal to 2 micrometers, N dash of this possible. X equal to 0, I am getting N dash of 0, 10 power 14 only now. Catch my point. I am in need of N dash of X equal to 2 micrometers. Means I want this value. How I can get? How I can get? From this point to this point, I am having the N naught value here now. This is to be taken N naught plus, these are the charges only, from here to here possible, this point. But at this point is nothing but what I can take now, this concentration, how I can get now? N dash of this value will be calculated by exactly that concentration we can find. This concentration I want. Only this portion only. I am not taking the here N dash. This is nothing but N dash, don't put N is best only this word. You can use N here now. Why this is N means, from this point to this point, N equal to X equal to 2 micrometers now. From here to here, I have taken N naught. From this point to this point, I want to take N dash of X equal to 2 micrometers only. These two addition will give the total concentration from here to here. Catch my point. What is N dash of X for 2 micrometers now? This value is calculated by, there is a formula. N dash of X equal to what? Any value here now. 2 micrometer or 1 micrometer or something, whatever it may be here now. But N dash of X equal to N naught into e power minus Xn by Ln I can write. By using this formula only, N dash of X is calculated. I can write here N dash of this X equal to 2 micrometers only now. I can write N naught of what? N naught means this we can write directly, N dash of 0, N dash of 0 at X equal to 0 only. N dash of 0 into e power minus Xn by Ln. I can write N dash of 0 into e power minus Xn by ln I can write directly here now. Now directly I can write now. What is n naught? N naught is nothing but n naught value is a known or unknown value. It is unknown. That value is nothing but the minority carriers which are existing in the p-type extrinsic semiconductor. Minority carriers in the material can be calculated by using what action law? Mass action law only. By using the mass action law, we need to calculate what is n naught. I say here n naught is nothing but ni squared by majority carriers. Mass action law I apply. Ni squared by mass Na. Na equal to 10 power 17. Ni squared 10 power 10 squared 10 power 20 divided by how much? 10 power 17. It becomes 10 power 3 per cm cube is possible. Per cm cube is possible. That much concentration here possible, minority carriers only now. But I want the what now? From here to here I want total concentration means n of x equal to 2 micrometers I want. That is nothing but n naught I got 10 power 3, n dash of 0 we got n dash of 0 10 power 14 into e power minus xn. Xn you got xn what now? X of xn means what now? X value only now. It is not xn, x only, sorry. X value how much? 2 micrometers only. X equal to 2 micrometers, not xn, x we can put now. This xn not required, x we can put now. X is nothing but the what now? 2 micrometers. But x is at micrometers, L also what now? Micrometers only. Micro cancel, 2 by 2 is possible now. 2 by 2 is possible. Finally, we can write 10 power 3 plus 10 power 14 into e power minus 1. Now use calculator, what value it comes? Anybody can use calculator? I'll give the value, please watch. That value will be like this now. (0.37 10 power 3 plus 0.37 into 10 power 14 into 10 power 14 is possible. That much value is possible. Now try to catch my point. But I want the concentration at x equal to 2 micrometers means from here to here I want now. But here 10 power 3 is a very small as compared to 10 power 14. As compared to this value is a very, very small. Whenever it is a small, I can neglect this value, no doubts. This value becomes very small as compared to that value. Finally, it is approximately equal to how much I can write? 0.37 into 10 power 14 per cm cube is possible. Per cm cube is possible. 0.37 into 10 power 14, we can say 0.37 to 10 power 14. Option A is correct, I can say. This option is correct. Which option is correct? Option A only here correct. This problem will come. Followed or not followed? Any students are having any doubts regarding this problem? Any students are having any doubts? You need to understand at first. N dash of 0 means at x equal to 0, n dash of 0. Total n of x, how I can get? N0 plus n dash of x equal to 2 micrometers, we have to calculate. At 2 micrometers, how we can get? Formula I gave it, n dash of 0 into e power minus x by ln. Apply the formula, you will get answer only now. That way we can tackle now. And we can go to next question now. I would like to go to next question. The GATE 2022 is a theoretical question, it is given now. It's a very simple question, anybody can understand easily. Any student can give answer for this question without my help. I am not going to open my mouth, I am going to keep silent for some time. I will see how many students can give answer for this question without my help. Anybody can do this question? Anyone can give answer? Anyone can give answer for this? You take some time and give answer. GATE 2022. Anybody? Any chance? If there is no chance, I am going to do. Shall I explain? If you are responded, I will get motivated and still I can do more number of problems and more information also I can deliver. Your response is more important. Without your response, we will not get interest of the more also. Please try to respond. Yes, I will explain. Please watch. Select the correct statements regarding semiconductor devices. Which statement is correct out of these four is asking here now. The option A is given, electrons and holes are of equal density in an intrinsic semiconductor. Electrons and holes are of equal density in an intrinsic semiconductor at equilibrium. Is it a true or false? Anybody can say, is it a correct or wrong? That statement, anybody? Is it a correct statement or wrong statement? Anybody? 100% that statement is a correct only now. What it says, electrons and holes are equal. Electrons and holes are equal density in an intrinsic semiconductor only. You know very well, for intrinsic semiconductor, concentration of electrons, concentration of the holes are equal. But N equal to P, that equal to Ni also we can say, that equal to Ni, intrinsic concentration. Anyhow, concentrations are equal. Electrons and holes are of equal density in an intrinsic semiconductor. 100% it is a true, it is a correct statement. I can say this is a true statement only, correct statement now. But we cannot stop there itself now. We can check other points also. We can understand clearly. Collector region is generally more heavily doped than base region in a BJT. Is it correct or wrong? Collector region is generally more heavily doped. Collector region is heavily doped, he says, as compared to the base region in a BJT. But that point is 100% false only. If you have taken any transistor structure of the transistor, if it is taken now, emitter, base and collector you can have. I am writing here now, you can understand clearly. But here you got the transistor with, this is the emitter, you know, this is a base, you know. This is nothing but what? Collector only, we can say now. Anyhow, 3 electrodes we can have. But where the concentration which is existing in the emitter is nothing but the Ne concentration. The concentration at the base is nothing but the Nb, you know very well. The concentration what is existing at the collector is nothing but the Nc only now. Those concentration had by these now. But the lengthwise, length if it is taken, collector region length is a more possible. Ne is nothing but the moderate, Nb is a very small length only possible. There is a length if it is taken, this length is more, this length is next level, this length is a third level only possible. What about the concentration? If the comparison of the concentration is made, how the difference will be possible here now? But you cannot say if it is a length is a more means their only concentration is a more. It's not acceptable now, 100% now. But a emitter concentration, because from the emitter onwards, you are going to send the carriers only now. That's why Ne is always very large. Emitter concentration is a very, very large. Very, very large. As compared to the base. As compared to the base only. But these two you compared means Ne is a large, Nb is a small only now. Nb and Nc, if you made a comparison, Nb is always large, Nc is a very small. Per cm cube, I am not saying now total length, per cm cube, concentration existing at the base is a large as compared to the collector only now. That's why Nb is greater than what? Nc only possible. Based upon this, the design of the transistor will be made. Once asked that gate question, that also they know. Anyhow, but here the point what is given here now, the collector region is more heavily doped. Yes, collector is not heavily doped, it is a less doped only. As compared to what? Base. As compared to base, collector region contains more, he says. It's not true only, no. It is untrue. It is a false only, we can say. That is why we can say this is false. This is false, I can say directly. This can be taken as a false. That can be taken as a false only here now. And third point, we can say total current is spatially constant in a two-terminal electronic device in a dark under steady state condition only now. That's a true point only. That statement we can't do anything now. That means total current is spatially constant in a two-terminal electronic device. In two-terminal electronic device, dark under steady state condition, it is a constant. 100% is a true statement only. That statement, no more explanation you can have. Still you want to go means it takes a time only now. Anyhow, that's a true statement only now. And the mobility of electrons always increases with the temperature in silicon beyond 300 Kelvin. That means 300 Kelvin, beyond 300 Kelvin, temperature you are increasing more than 300 Kelvin, you think it so. He says mobility of electrons also increasing. We know very well when the temperature we are increasing means mobility also increases. That is up to some extent only now, up to some extent of the temperature only. For every temperature now it is not going to rise. Less than or equal to 300 Kelvin if you maintain, you can find the slow increase of the temperature only now. Once it is crossing the 300 Kelvin, you think it's so. Immediately what is going to happen now? Electrons mobility will be decreasing. Sir, when the temperature is increased, how can you say the mobility of electrons also decreases now? Whenever the more temperature it is given to the material now, electrons are going to absorb that temperature now. They will be excited more. When it is excited more, they are not going to move in a straight direction. They are going to move in a zigzag path only, we can say. When the temperature is low, they are going to move in a straight direction. When they are moving in a straight direction now, easily they are going to reach to the next terminal only now. When they are moving in the zigzag path, it takes a more time to reach to the terminal point only now. That's why they will say here now, when the temperature is increased more, increase more than the 300 Kelvin temperature, what we can say, the mobility of electrons will be decreasing only now. It won't be increasing only now. That's why this is a false, 100% it is a false only, we can say, this point. Finally, this is nothing but MSQ question only now. Because of the MSQ question, what now? Here the two options we are getting now, right only now. So I got here now solution I can put directly. Here now. The solution for this question can be taken as a solution is option A is correct. It is a true statement is asking. A is correct and also what? C also correct only now. These two are correct only, we can say. C and A are correct in this problem. These two options are correct. This is one of the gate question in 2022, I can say. I want to go to next question now. This is one more gate question. Anybody can do this question without my help? Anybody can do without my help this question. The students must respond. If the students are not responding, I cannot get whether you are following or not following me now. If you are reacting here now, you are responding, you think it's so. Immediately what happens now, I can give you more information. I can deliver more information only now. Understand? But don't miss the classes now. Each and every day you try to attend. You'll get some information only now. Understand? 5 years EDC papers I will do. Today I did 2022. Last week, yesterday I did 2023. The next class you can see 2021. Like that 5 years papers. After completing this EDC, I will start analog also for 4 years, no doubt. Understand? Anybody? Anybody can do this question? Anybody can do this question? Initial work is yours. I don't want to do directly this question. I want to wait for some time. Any student can give answer for this question. Nowadays, MOSFET is given much importance to the gate. It's given much importance now. Anybody can give answer? Shall I do this question? Yes, I will do. Please watch. An ideal MOS capacitor. This is one of the MOS capacitor only. Metal oxide semiconductor. These three metal pieces are combined. That is a MOS capacitor, we can say. But a semiconductor is nothing but a p-type semiconductor. P substrate also we can call. It's a p-type semiconductor. It is shown in the figure. The MOS capacitor is under strong inversion with gate potential equal to what? 2 voltage. It is in the strong inversion only now. Because you know, but the the conduction of the this will be done by 3 ways only now. Accumulation and depletion and inversions, you know very well now. Understand now. But anyhow, Vg is given 2 voltage. The corresponding inversion charge density Qin is something. I will write here now. Clearly you can understand. I will write here now. You will follow. But I want to take this solution. Here I want to do the solution. It is a MOS capacitor, you know very well. Here it is given, it is a gate potential is given 2 voltage. Gate. But in the MOS capacitor, emitter is always what now? Grounded only directly. Vg or Vgs also we can put. It's not a mistake. The gate potential and Vgs, Vg minus Vs. Vs voltage is a grounded only mostly. Okay, that's a Vg or Vgs. Vg equal to 2 voltage we can put here now. Vg equal to 2 voltage is given. Vg or Vgs also we can put now. 2 voltage. Source voltage is always what now? Shorted only now. Understand now. Vg minus Vs, Vs becomes 0. That's equal to Vg only 2 volts. And that is a 2 voltage it is given. No problem. The next one, what is given here? The corresponding inversion charge density. That means because at this particular gate voltage, what charge density is possible? For this MOS capacitor, the MOS capacitor can get the charge density of 2.2 microcoulombs. The charge density of Q inversion, Q inversion, 2.2 microcoulombs per cm square. That much amount of the charge density is possible at that particular voltage. Understand my point now. And still what is given in the problem? Assume oxide capacitor per unit area is COX is 1.7 into 7 microfarads per cm square. COX means you know the capacitance of the capacitor per unit area. It is given here now. COX is given here. We can put COX is nothing but that value is given 1.7 microfarads. 1.7 microfarads per cm square it is given. Per cm square it is given. That much value of COX is given in the problem. And also here given few more parameters now. For Vg equal to 4 voltage, Vg can also be taken Vgs I said now. Vgs is nothing but 4 voltage. Vgs or Vg is a 4 voltage. Vg equal to Vgs equal to 4 voltage is given. The point you watch here, the Vg is given, we can assume this is a Vg1 best. This we can take it as a Vg2 only now. Gate potential is given 4 voltage. In that case, I want Q in value how much? But I want what is Q in. Is a Q in for first case. Is a Q in for second case equal to how much? Is asking. That value is very important now. How we can measure? We know very well the charge equal to what? Capacitance of the capacitor into the voltage only now. But you know from the electrical network, in the networks you will say Q equal to CV, capacitor into the voltage you will use now. Based upon the same concept we are going to do this question now. Here the point what I wish to say, the V, but charge Q in inversion charge density is equal to COX into VGS minus VT only now. Just like a capacitor into some voltage is nothing but the charge we are going to get only now. That formula generally used in the mass capacitor. The mass capacitor use inversion charge calculation. We know very well, but at Q in 2 required, Q in 2 means COX into VGS 2 into VT. VT is a what now? VT is a constant value only. That VT is a constant value only now. That value only now. Understand my point now? Here the point what I wish to say, Q in at this Q in 2, if you want to find VT is very important now. Without knowing VT value, I cannot determine Q in 2 only now. By using the what now VG1, Q in 1 and COX, I can determine VT value. Once the VT value we got, I can determine Q in also very easily now. Q in 2 I can determine. I say initially I would like to find Q in 1 equal to COX into VGS1 minus VT. That I have taken now. We know very well Q in 1 is given 2.2 microcoulombs, 2.2 micro, 10 power minus 6, and COX is given 1.7 micro into 10 power minus 6, and VGS1 is given as a first case, VGS1 2 voltage is given, VT is unknown. Yes, you can determine what is VT value here now. Use the calculator and please give the VT value. Anybody can give this VT value? What VT you are getting? Please give me. Yes, otherwise I will give. Please watch. That value will be. The threshold voltage is 0.706. 0.706 volts possible. That much voltage is possible. But once you got that threshold voltage, now it is very simple to determine Q in 2 here now. How I can determine? I will get the value this side. The Q in 2 is nothing but Q in 2 I can get from what now? COX, that will not be changing. VGS2, VT will be constant here also. That same VT will be maintained, threshold voltage. But as COX is same, how much? 1.7 into 10 power minus 6 I can use. And VGS2 is nothing but, here given the problem, VGS2 is nothing but the 4 volts. VT we got as a 0.706. 0.706 I can write now. Now you can get what is Q in 2. Directly you can give that value. That value will be, I am giving that value. Five point six microcoulombs per cm square. Yes, that much value is possible. That is Q in 2. But I hope you followed. It is not a tough question. Very easily you can do this now. There is the question was asked in the GATE 2022. I will go to the next question now. I will try to do the next question now. The next question is, just wait. There is one more GATE 2022 question. There is one more GATE 2022 questions only now. Anybody can give what is the answer for this question? Any student can give answer for this question. You take some time and give answer, but I want to wait for some time. Any student can give answer? You take time and give answer. You must try. You need to maintain one book and also pen. When the problem was here displayed, immediately you start doing and give your answer also. Yes, I will do. Please watch. I will do now. You'll understand. Consider the CMOS circuit shown in the figure. Substrates are connected to their respective sources. The gate width W to gate length W by L of the transistors are as given, and the transistors have the same gate oxide capacitance per unit area. And here the PMOS and also NMOS are given now. PMOS and NMOS here given. PMOS and NMOS. Finally, it is a CMOS. You know very well. And here the data is given. You watch. For the PMOS FET, the threshold voltage is given -1 voltage. I will do here. You can understand clearly now. I will do it. Threshold voltage is given for the PMOS. VTP. P indicates for the PMOS FET. How much it is given? -1 volt it is given. -1 voltage it is given. The mobility of holes it is given. Mobility of holes. The mobility of holes here given 40 cm square per volt second. 40 cm square per volt second. It is given. For the NMOS FET, the threshold voltage is 1 volts. For NMOS FET, it is given threshold voltage VTN we can use. That is equal to 1 volt. It is given. And the mobility of electron is 300 cm square per volt second. It is given. The mobility of electrons here given as 300 cm square per volt second. It is given here now. Mobility of electron. The steady state output voltage V0 is asking to measure what is V0. That voltage is required. The PMOS and NMOS you are having here now, but how they are going to operate? They are in the mode of saturation or triode mode or cutoff mode. Anybody can say? In what mode of operation you will find these two MOSFETs? What mode of operation here possible? But you try to catch if the drain and gate are directly shorted, you think it's so. You can say directly that MOSFET is in saturation only. Here the P MOSFET you watch, this becomes a drain, this becomes a source, this becomes a gate. This is directly shorted. Drain and gate is shorted. For the N MOSFET, this becomes a drain, this becomes a gate, drain and gate are shorted only now. Both are shorted now. At the time you can say it is these two are in saturation mode only now. Whenever these two are in saturation mode, you can write what formula is there now. Saturation mode, what drain current is passing, you know very well. Here the point what you have to remember is what drain current is going to flow this side, ID1. Same drain current is going to flow this side also, even here also. It will be same. ID1 and ID2, same current one now. We cannot find any current at the what? This gate side. Because the input impedance of these is what now? MOSFETs are very high. If it is taken the JFET, you can find in mega ohms. If it is taken the what now? MOSFET, you can find in giga ohms also. That much large resistance is possible now. But input current is always approximately equal to 0 only. That's why ID1 and ID2 are equal. I can say here ID1 equal to ID2 only possible. ID2 is possible. So when they are in what now? Saturation, we know that very well. Drain current equal to what formula we can use? What formula you can use for the drain current? But they will apply this W by L is given 5. W by L means aspect ratio. W by L for the N MOSFET, that is the aspect ratio of the N MOS also given here now. But how the formula is applied? Mu N into, they will apply the formula mu P. First one is nothing but the P MOS. Mu P into COX. COX is same for both. COX into by 2 into W by L for the P mass into what? If it is a P mass VSG minus threshold voltage of P whole square. This is the drain current formula when it is in saturation. This is equal to ID2. This is equal to ID2. ID2 means what now? That is a N mass drain current is required. The drain current for the what now? N mass is nothing but the mu N into COX by 2 into W by L of N into VGS minus VT. My God. Just wait. I'll write here now otherwise. I'll write here now. But this is equal to, I can write that equal to, this value equal to, I am writing, this is ID1 equal to ID2. ID2 means mu P into COX by 2 into W by L into E of N VGS minus VT whole square you can apply. That formula is possible. But I can cancel 2 and 2 on both sides. I can cancel these 2 and these 2. And COX I can cancel. Both sides COX can be cancelled. The what is mu P is given here now. Mu P is nothing but 40 cm square per volt second. 40 possible. W by L of P type P MOSFET. W by aspect ratio is given here 5. VSG means this voltage. VSG, source to gate voltage. If it is in saturation, this voltage and this voltage will be same. Source to drain and what now? Source to what now? Gate will be same because it is a shorted. That's why VSG equal to VSD also. VSD means 4 minus V naught. 4 minus V naught. 4 is this voltage is a 4, this voltage is a V naught, 4 minus V naught is a VSD, I can write. And minus VTP modulus only, minus 1 with modulus means plus 1 is possible now. Minus of plus 1 possibles. Whole square is possibles. And here I can write mu P or mu N this side. This side is a mu N, sorry. This is a mu N, mobility of electrons we know. Mobility of electron is nothing but a 300 here into W by L. Aspect ratio for the N MOSFET is nothing but 1. VGS, this is a gate, this is the source. VGS means this voltage same V naught. Here you can have same V naught. V naught minus 0. VGS is nothing but V naught minus 0. That means V naught only possible. Minus VT is nothing but the 1. We know VTN is a 1 whole square. And expand the whole equation. You will find what is V naught. Anybody can give what is the value of V naught without my help you give me? Please give the value of V naught. What V naught we can get? Anybody? What V naught we can get? What V naught you can get? How much you are getting? Anybody? Anybody getting value? What V naught is possible? I am asking question. And you try to simplify this and find out the voltage V naughts. Some voltage you can get now. Just simplify and find the V naught value. Just expansion only, nothing more. That work you can do easily now. Like that we can do the problems only now, understand. But I want to close the class by this problem only now. In the next class, we can see the 2021 question now. Don't miss the class. I hope you satisfied with the what now? Problems. You satisfied with the what now? The way of teaching and the type of the problems we selected in this session only now. Thank you all.